So with that, let me please introduce to start Daniel Jiménez. Daniel is with CIAT. He's a scientist at the International Center for Tropical Agriculture, and he's going to tell us about big data and site-specific agriculture to support rice farmers in Latin America. Daniel.
So good afternoon, everyone. As he said, my name is Daniel Jiménez. I work for the International Center for Tropical Agriculture, and the idea with the presentation would be to share with you our experience in Latin America working on big data and site-specific agriculture to support rice farmers in Latin America. Actually, the case was already showcased in a document released by GODAN and the Open Data Institute last year, as we're going to see in the next slide. And then I will briefly highlight what were the challenges that we were facing, what was the way how we faced such challenges, what we propose from the science perspective, and by the end I will talk a little bit about what this is exciting from the open data perspective. So as I said before, the particular case of Colombia, the rice systems in Colombia was showcased last year, and basically what we used was both open data and private data in order to support the countrywide growers association in the identification of the complex and region-specific issues behind the decrease in rice yields. Actually, since 2007, production of rice in Colombia started to decrease, so we didn't know what was the cause, but climate change was one of the suspects. And actually, that is something that not only happened in Colombia, but also across Latin America. In the north of Colombia, for instance, the same farmers that 4 years ago had their terrains flooded, last year went through a very dry season. But that's not an image from Colombia. That's an image from Uruguay this year, the first semester. In 2012, I went to Uruguay, and I started to talk with them about what we were doing in Colombia, mining data, and site-specific approach, and they say that climate change wasn't an issue for them. Well, this semester, 14% of the total area grown in rice was affected by climate change. There were like $67.8 million of losses attributed to unexpected rains in Uruguay. So that's definitely an issue in Latin America, and if on top of that you think that the way how farmers make decisions in Latin America on how to grow or where to grow are based on the successful decisions that they make on the previous season, that's not really a very accurate or reliable way to make decisions on what we should be growing. So what we proposed, in the particular case of Colombia, we analyzed the main site-specific climatic limiting factors. How we did it? The FEDARROS, which is the countrywide growers association, they've been collecting information over the last 20 years or so, information on planting and harvesting date, productivity, variety. These and different databases that were used for different totally purposes. But then we started to work with them and say, look, maybe we can combine the information that you have in those databases with climate information provided by the meteorological institution in Colombia, which is called IDEAM, and see if we can identify those climatic factors associated or that might have an influence on the variation in crop yields. And good news here, in terms of open data, is that the IDEAM, the meteorological institution, since 2014, they should make the data available to everyone, as long as you give them credits for the work that they have done. So, just briefly to share with you some of the results is that we have determined, for example, how the varieties were sensitive. This is the results for one specific region, one specific variety, which the climate accounts for about 30% of the variation in production. The variety is called FEDARROS 733, and we have determined the most limiting factors, and by using machine learning algorithms like conditional inference forest, we have determined, for example, the functional relationship between production and one of the most relevant factors, which is average minimum temperature in the reproductive stage. And for those familiar with traditional analytical approach, you know that in the past, the analytical approach, you can just only determine if it was a negative or positive relationship, but not really the optimal range or the inflection points that can tell you basically what are the optimal ranges. And we did the same for the amount of fertilizers and soil properties. But the most important result for the Growers Association was not which variety performed necessarily better in this place. In this case, this variety was just 30% sensitive to climate. Some other varieties were 60% sensitive, and some others 10. So basically, we've been recommending varieties that are not suitable for that particular place. And this is the type of decisions that we're supporting. We support FEDEARROS, the countrywide Growers Association, to recommend the varieties that should be grown in particular places. Some of the reasons why this is so exciting: 3 weeks ago, we published those results in an open access journal called PLOS ONE. And when you publish in these journals, you have to make the data available. So we did it through a repository called Dataverse, part of the policy of the centers like CIAT and those that belong to the CG network. Now it's a policy to the open data. So that's why we have this agreement with Harvard University to put the data there. Of course, one of the technicians from FEDEARROS is part of the AutoChip list. And if in the beginning of the presentation I say that we used both private and public information, we can proudly say that now all the information is available to everyone, so it's public. Some of the reasons why this is so exciting is that it enabled one environment of cooperation. That image on the right is an agreement in Argentina with us, with the FLAR, which is a continent-wide Growers Association. And they basically are the institution responsible for soil information, crop management information, climate information. They not only wanted to know what are the climatic factors associated with yield, but also soil crop management. So this type of approach enabled that. They signed up this agreement a month ago. And last but not least, this is an approach that more than 5,000 farmers have adopted in Latin America. We have analyzed more than 50,000 cropping events. And in 6 countries, we scaled up to Peru, Nicaragua, Argentina, Uruguay, and more recently, Mexico. Thank you very much.